Welcome to my next video. So here we're going to solve the question from statistics, mean, mode and median. So in the question, it is given the annual rainfall and the number of subdivisions. So in question number 1, it is asked the model class. The model class will always correspond to the highest frequency, and if you see the frequency highest, the highest number is 7. Therefore, the model class becomes 600 to 700. Now, in the second question, it is asked to find the median. So for finding median, we need to find at first the cumulative frequency, that is CF. Now, how to find CF is very simple. We have to take the terms from the frequency Fi. So see, the first term is 3, 3. And the next term would be simply the add-on. Just like 3 plus 4 equals to 7. 7 plus 7, 14. 14 plus 4, 18. 18 plus 3, 21. 21 plus 3, 24. Now, the sum of the total all term of Fi, that is summation of Fi, should be equals to the last term, that is 24. Now, this is the formula for finding median: L plus n by 2 minus CF, F, and H. So we need to find all these terms from this table. Now, n. What is n? N is the Fi, the sum of all the term of Fi, summation Fi. That is, it is 24. N by 2, simply dividing 24 by 2, we get 12. Now, CF. See, 12, we have to come to the cumulative frequency. There we see where 12 lies. 12 lies between 7 and 14. And we have to take the lower part. The lower part is 7. Therefore, CF equals to 7. Now, considering the upper part, we have to move straight ahead. We get F. So our F is 7. And moving ahead, we find the lower limit, that is L, 600. And H, the difference, that is 200. Now, substituting this value, we find the median. So here 600 plus 12 minus 7 by 7 into 200. 5 by 7 into 2, that is 1000 by 7. And on division, we are getting 142.86, and addition we have 742.86. So this is your median. Moving to the next part, B. So in this, we have to find the mean of the data. For finding mean, we have three methods: direct method, assume mean method, and step deviation method. So here we are applying step deviation method. Seeing the complexity of the number, step deviation method will make the calculation much simpler. So before that, we need to find xi, di, ui, fi, ui. And how to find xi is very simple. We have to take the middle term of the interval, that is 400, 200. The middle term would be 300, 600, 400, that is 500. So likewise, we time all the middle term of the interval. After finding the middle term, we'll move to di. For finding di, we have to consider a middle term from the xi. For example, we have considered 700 as the middle term, and now we are subtracting xi minus 700. So 300 minus 700 minus 400, 500, 700, 200, 0, and likewise. Now, ui. How to find ui is very simple. We have to divide di by the gap of the interval, that is di divided by 200. So we're getting minus 2, minus 1, 0, 1, 2, 3. See how the numbers become small. So the calculation will be very simple. Now we need to find fi ui. It's very simple. Fi we know is 3. Ui we have 2. That's minus 6, 4, 1, minus 4, 7, 0, 0. Then 4, 1, 4, 3, 2, 6. And so on the summation, we are getting fi ui equals to 9. Now, using the formula for step deviation, it is given as a plus fi ui by fi into h. And what we know, a, we have considered a here is 700. So 700 fi ui is 9, fi 24, h equals to 200. On substituting the values, 709 by 24, 200. Okay, 1824, 75. So what we find mean here is 775. Moving to the next question number 3. If a subdivision having at least 800 millimeter rainfall during the monsoon is considered a good rainfall subdivision, then how many subdivisions have good rainfall? Now it's the bar is here is at least 800 millimeter. So now we have to consider all the values that are more than 800. More than 800. So number of such stations that have receiving rainfall more than 800 are 4, 3, 3. So our answer would be 4 plus 3 plus 3, that is 10. So the answer for the third question would be 10.